The first problem we will be doing is number 1. In this problem, we're trying to find which compound has the higher number of lead ions. First, what I did was I found the molar mass of lead in chlorine. Then I used these numbers to add it up to find the molar mass of the compound. First, you do 100 grams over 1 times 1 mole over the total number of grams of the entire compound. You do this to cancel out the moles, to cancel out the grams so that you can go into moles and then find the atoms. Then I multiply by Avogadro's number to transfer the unit into atoms. After, I multiplied the number of lead ions over the entire compound's mass to find the proportions and to find the percentage of lead in the entire compound. This number led to 2.24 times 10 to the 25th. I did the same for the other side, except this one was Cl3, so it had one more Cl, which was one more 35.5 grams. So I multiplied 1 gram times 1 mole to cancel out the grams over 3.3.7 grams, which is the total mass of the compound. After, I multiplied by Avogadro's number so I could cancel out the moles and go into the unit of atoms. Then multiplied the total number of lead out of the entire mass of the compound to add the percentages of lead. This gave me 1.98 times 2, 10 to the 24. My conclusion was that PbCl2, or lead 2 chloride, has more lead ions because it is a bigger number and it has a bigger number in scientific notation. The next problem we'll be doing is number 2. Number 2 says that the LD50 of lead is 20 milligrams over kilograms. However, we have the number in pounds. So first what we have to do is transfer the pounds to kilograms, which says over here that 1 kilogram equals 2.2 pounds. So I multiplied by 1 kilogram over 2.2 pounds in order to cancel out the pounds and give us 200 pounds in kilograms. Then I multiplied by the LD50 to cancel the kilograms and go into milligrams to find what mass of lead would be fatal. This gave me the number 1,809.95 milligrams. Next, number 3. Number 3 is asking us to find the number of oxygen atoms in 1 kilogram of glucose. This is similar to problem A. First, I multiplied the total number of kilograms in the entire compound, or the amount. Then I multiplied the number of grams in a kilogram so that I could change the unit from grams to kilograms, or change the unit from kilograms to grams. So I multiplied 1,000 grams over 1 kilogram because there are 1,000 grams in 1 kilogram. Then I multiplied by the molar mass of glucose, which is 180 grams, by adding up the mass of carbon, hydrogen, and oxygen, which would be, it adds up to 180, but the math would be 12 times 6 plus 12, because hydrogen has a mass of 1, plus 6 times 16. 16 is the mass of oxygen, which gets you to 80 grams. Then I multiplied 1 mole over 180 grams, which is the molar mass of the entire compound, so that I could then take away the grams and go into moles. Then I multiplied by Avogadro's numbers so that I could get the number of atoms, because we were trying to find the oxygen atoms. Then I multiplied by the number of oxygen atoms in here, which would be the 6 times 16 over 180, which would be 96 over 180. Then I got 1.9 times 10 to the 24 atoms. Finally, number 4. In number 4, we're trying to find what element has 3.01 times 10 to the 23 atoms in 100.5 grams. First, I made 100.5 grams the numerator because I know that this number of atoms has to be inside of this total number of grams, which is the molar mass. So they gave us 3.01 times 10 to the 23. First, what you have to do, or after putting them under the molar mass, you want to multiply by Avogadro's numbers so that it would divide and find the number of moles from this number of atoms. Well, after doing this, I got 201 grams. And if you look on the periodic table, you can see that mercury right here has 200.59, which we can round to 201 grams. So therefore it's mercury, and mercury is a metallic element. So that's how you solve it. Thank you.